Hi, my name is Duncan, and today I'll be showing you a quick demo of JITPCB, which will be a new way to design circuit boards online. The thing that's different about JITPCB is that it automates the entire design process. So I just say what I want, and JITPCB designs the circuit board for me. So I've got my text editor open here, with a default template loaded. Default template powers the design over USB, but I want to use a screw terminal, which is a Phoenix screw terminal with 2 pins, and instead of 5 volts I have a field source at 48 volts, so I need to change that, and I'm going to say that ground is on pin 0 and the positive reference is on pin 1. So if I build this right now and use KiCad to view it, let's see here, I have to refresh, here we go. This is my design. So I've got a screw terminal, the particle electron, and a buck converter, which steps the 48 volts down to 5 volts. We're using a 4-layer stack-up with internal power and ground planes. And so if I turn those off, you can see that, here's like the particle electron powered off of 48 volts. And this is what our user interface is going to look like. You have a scripting window over here, and then your board gets rendered over here. And we're improving our algorithms to make it very interactive, so your board just kind of appears as you describe it without having to do any manual updating steps. So I need to customize my board a little bit more because I have an enclosure it needs to fit in. So I'm going to say the width is 52 millimeters, the height is 85 millimeters, and I also need some mounting holes in the corners. So I'm going to say there's a mounting hole, and I'm going to say the diameter of the mounting hole is 2 millimeters, and I'll spell diameter correctly. So this will put a mounting hole on the board, but it'll just put it where it fits. So the location is important, so I'm going to use our location command. So say it's at a location, minus 24 and 40 millimeters. So this is going to put it in one of the corners of the board, and I want another one in the other corner, so I'll go ahead and add that. And I'll switch the minus sign and build it. And I have to refresh KiCad, unfortunately. Okay, so here I've got the particle electron, the buck converter, and the screw terminal, but the board is now customized to the shape I want. So now this will fit in my enclosure, and I have all the right mounting holes. I also want to add some buttons and LEDs so I can interact with the board. So I'll say there's button, and these have to be placed specially so they line up with features on the enclosure. So I'm going to use the location command again. So at location, and do a little sublime text here. So it'll be a row vertically around the top, so everything will be at 40 millimeters. I've got 5 of these buttons, and then I want to say they're spaced out at 5 millimeters. So starting at 20, going down by minus 5, and there we go. So this will be a row of buttons, and then I also want a row of LEDs. So here we have LEDs, and these will be spaced out below the buttons, let's say by 3 millimeters, which puts these at 37. Alright, so if I build that right now, alright, so this is going to take a little longer to place because there's more components. But what it's doing is placing all the buttons, placing all the LEDs, and then also placing all of the passive components like resistors and capacitors that you need to make them work. And it's also connecting up all the pins to the particle. So it takes a minute to do that. But if I refresh KiCad right now, okay, it's done. And let's get the board open. So you can see things are getting a bit more complex. I've got my buttons along the top here, I've got my LEDs underneath, and here's all the resistors and capacitors you need to make that work. So LEDs get a pull-up resistor, and the buttons have a low-pass filter to debounce the signal. Then I have my screw terminal and buck converter. So that's a good start, but now I have a sensing board without any sensors on it. So I want to sense sound, so I'll add a microphone. I want to sense vibration, so I'll use an accelerometer. Or 2, why not? And I also have a off-board temperature sensor I want to use, So I need to power it off of 3.3 volts, and it has a UART interface. So I'll use a connector. Connector. And it'll be the same screw terminal family, but a 4-pin version. And I have 3.3 volt power on, let's see here, I have ground on pin 0, and I have 3.3 volts on pin 3. And then I have UART, and I've got my transmit line on pin 1, and I have my receive line on pin 2. And finally, I want to save data locally, so I'll add a micro SD card. And now we're going to build it again. And like before, this is going to take significantly longer. So while it's running, I'll get into what it's doing. So right now, it's basically populating all of the components. Everything I didn't specify a location for, it's going to find the best place for. And then it's going to assign all of the pins, so making sure everything gets matched up to the right interface on the particle electron, and then route all of the wires. So all of my design details are handled computationally, and because of that, they come out correct every time. And that includes all of the manufacturing constraints. So we've programmed in all of the information from the manufacturer so that this board will pass any of the DFM checks. So it's literally ready to go when it comes out of the system. And it takes about a minute or two to design this board, but that's still faster than I could do it. And it's finished building, so let me show you the updated result. Alright, and here it is. So we've got the UART connector here. So this is my ground, 3.3 volts, and then my UART lines here. These are my accelerometers here and here. The system has connected them over I2C, added pull-up resistors on the communication lines, and configured the address pins so that I don't have any address conflicts. This is my microphone down here. We're using a bandpass amplifier with that. And finally, here's my micro SD card. And so if I turn off the copper layers, you can see the traces more clearly. So everything has been matched up correctly. All the traces are routed, all of the pins are assigned, and because we've modeled the particle electron, it all gets done correctly and within about a minute. So now I have my custom circuit board design ready to go. So all I had to do is describe what I want, and then JIT turns that into a ready-to-make board. And that's our demo. So thank you for watching.